Okay, hello again, part 3. So for regression, we make one more change to the standardization, to the scaling, which is just to divide every element by 1 over the square root of n minus 1. Okay. So let's write it down. So for linear regression, for MLR or SLR, we make an additional scaling and define y star equal to the vector the same as before, y minus y bar over sy. But now I multiply by 1 over the square root of n minus 1. And actually, if I do that, you see the 1 over the square root of n minus 1, the square root of n minus 1 multiplies sy, and it cancels out the square root of n minus 1 in the denominator there. So this is equal to y minus y bar over the square root of the sum of yi minus y bar squared, 1 to n. And I'll have xk star is equal to, again, same thing. Everything gets multiplied by the same thing, so it really doesn't affect the system, the inferences. This is, sorry, I should, xk. So this is equal to xk centered minus xk bar, and now the n minus 1 is gone, so I have the sum xk, xik minus xk bar squared, 1 to n. Okay. This is called the correlation transformation. All right. What this does is it, well, actually, let's do a practice to see what happens now if we implement this and see what happens. So if we let's do it on the same vector we had up here. So now so for example, for y equals the same as above, 0, 4, 4, 1, 6, find y star. Well, we already found y minus y bar, and then we already found sy and all that. So let's just do it again from the beginning. So here we have, let's see, 8, 9, and 6, that's 15. So the mean is 3. So y minus y bar again. So y minus y bar again. You have this already in your notes. Minus 3, 1, 1. I'll give you another one. I'll give you a new one to do too. 3. Okay, that's still that. But now I divide by the sum of all these squares. So I get what? 9. There's no n minus 1 anymore. I have 9, 1, 1, 4, 9. What is that? 24 or something? 9, 9, 18, 24, right? So I divide by the square root of 24, right? So y star equal this over the sum, the square root of the sum. Is equal to this times 1 over the square root. Okay, what this does is, notice two things. One, elements still add to 0. but also 2 y star has unit length. I don't know what n is. It could be anything. It could be an R3, I could be an R4000, but the vector has unit length. So if n is a big number, yeah, each element will tend to be small, because when I square them, they'll get smaller when I square them, but still I'm adding a lot of them up, and they have to equal 1 in the end. So you can see I'm dividing by roughly 1/5 each place. So every single element is less than 1 there. And they'll get even smaller. If I have a big n, they could get quite small. So for you, let's do a couple practices. So say, so example 2, find y star. Let's just do a couple examples. Y equals 1, 0, 0, 1, say, and b. Y equals -3, 2, 0, 6, -1, -4. Okay? So when you get them, you should check. They should sum to 0, and they should be unit length. Now, this is what we want to be working with. Now notice, because we made the same transformation everywhere, in the sense that we first standardized them, and now we're dividing by the same number everywhere, we still have the same system intact, as long as we understand it to be, in terms of standard deviations, normalized standard deviations of each variable. All right. All right, so we're ready to get back to the model. I think, okay, yeah, I have a little more time. So now what we'd like to do is go back and interpret, go back to the model and see how we can apply the model. So in other words, we have these different, we've transformed each vector. This can be done, as you can imagine, very fast with one command in R or so, and then you can go from there. So how would we do this transformation in R? So in R, we could do a transformation like, so we could have, we could call it like y standard or something. If I don't want to do the divide by the square root of n minus 1 first, I could say this is equal to y minus mean y, and you can divide this by sdy. That's all you have to do. And then if you want y star, you just divide by the square root of n minus 1. So this would just be y standard, and you divide by square root n minus 1, whatever n is, in your data set. Okay, let's see. So that's straightforward. There's also, there's a command, use the scale command. Use command scale. This has a few options, but if you use it with no options, it gives you y standard. So so we would have y standard equals scale y, and then y star again equals, could do it that way, or I could go scale y divided by square root n minus 1, something like that. Okay. All right, well, I'm going to stop now and then get back to how we will estimate the regression coefficients.